Hello, this is Mrs. Ross, and this is lesson 62. We're doing the star problems. We did the practice set in a previous video, and you might want to take a look at that if that's what you're looking for. Otherwise, we're going to skip forward through the practice set to the first star problem. So, number 5 says use a ratio box to solve this problem. There were 144 books on mammals, about mammals in the library. If the ratio of books about mammals to plants was 9 to 8, how many books were about plants from the library? So this is the Dora the Explorer method. Ratio box, proportion, cross multiply. Here's my ratio box. Let's see, so it's mammals, books about mammals, and books about plants. So it says there were 144 books about mammals. That's an actual number, so that's going to go in the mammals row under actual. And then it says the ratio of books about mammals to plants was 9 to 8. So mammals to plants. How many actual books about plants were there? So my x goes here. This indicates what our proportion should be. So we have 9 over 8 is equal to 144 over x. We're going to cross multiply. So this is 8 times 144. My equals comes down. 9 times x. So let me go ahead and figure this out on my calculator. 144 times 8. And I get 152. My equals is going to come down again. I didn't do anything to the 9x. It just comes down. We need to divide to get the x by itself. So 9 over 9 is 1. My x comes down. My equals continues to come down, and I need to divide this. I have 128. Oh, lost my cursor. There we go. 128 books about plants. All right, number 7. Write an equation to solve this problem. What number is 5/6 of this? Okay, so what we're going to have to do is we're going to have to translate this from English to math language. When we have what number, that's normally x. So what number? X is equals 5/6 of times 3 1/3. So is going to be the equals, of is the multiply. Okay, so I'm going to go ahead and popcorn this. 3 times 3 is 9, plus 1 is 10. And we're multiplying by 5/6. Okay, so then multiplying two fractions, we multiply across the top, which is 50, and we multiply across the bottom, which is 18. This means we need to divide. 18 goes into 50. Let's see, 18 times 1 is 18. 18 times 2 is 36. 18 times 3 is too high. 54. Yep, that's what I thought. So this is going to be times 2, which gives me 36. I'm going to subtract to get my remainder. And I have 18 and 14/18. I'm going to need to reduce this by dividing by 2. So I keep my whole number, 2. This is 7/9. Okay. Show this addition problem on a number line. I'd rather not. I'd rather use the rules of adding integers. So if I take a look at these two integers, they are different signs. Remember that if they are the same sign, my adding rules, and if you don't have this written somewhere, you might want to. Adding rules are, if they are the same sign, add, keep the sign. If they're different signs, subtract, keep the sign of the larger. This only applies to when we are adding, and we are definitely adding here. So I have different signs. So 4 minus 3 is 1. Keep the sign of the larger. The 4 is larger. And then I'm just going to bring this down. Again, this is going to be an addition problem. My signs are different, so I'm going to subtract. 2 minus 1 is 1. Keep the sign of the larger. The 2 is larger than 1, so this is -1. All right, let's grab a different color here. Find each missing exponent. So if we have the same base and we're multiplying, we're just going to add the exponents. So this becomes 5 plus 3, which is 8. If we're dividing, so this could also be written like this. We're going to subtract the exponents, so 5 minus 3, which is 2. Okay, here we're subtracting again, so I have 2/3 over 2/3, which is 2 to the 3 minus 3, which is 2 to the 0. And here I have 2/3 over 2 to the 5th, which is 2 to the 3 minus 5, which is 2 to the negative 2. Okay, feel free to put any of these examples in your math spiral. Alright, in the figure below, ZWX measures 90 degrees. So this whole thing is 90 degrees. Okay. Which triangle is an acute triangle? So let's see, I'll do yellow, which I can't barely see. Here we go. So this one, that's acute. That's a beautiful acute triangle. So that's going to be, I can't do yellow. What made me think I could do yellow? So that's going to be triangle ZWY, which is obtuse. Let's take that blue. So the one that has, that's going to be 90. So let's see. Oh, I see it. Oh, doo-doo-doo. Hold on. So obtuse, this is an obtuse angle. So remember, obtuse is greater than 90. So my obtuse triangle is going to be, let's see, WXY, right there. And you can literally put these numbers in any order. It matters not, okay, when you're talking about triangles. Then let's see, let's do a red. It says, what's the right triangle? So since the right angle is there, this whole thing is the right triangle. So WZX is the right triangle. Okay, this says classify this angle by its sides. We have two sides that are the same. That's an isosceles triangle. What is the measure of each acute angle in the triangle? So I have a 90-degree angle here, and since these sides are the same, I know A and B are the same. Remember, if it's across from the side, the side and the angle that it's across from are related. So if this is 90 degrees, I know that the total number, the total degrees, if I add all of the degrees in any triangle anywhere, I get 180 degrees. So let me subtract out that 90. I have 90 left, which I need to divide between two angles evenly. So 2 goes into 90, and I get 45 degrees. So this is 45 degrees, and this is 45 degrees. This is 45 degrees. And then it asks, what is the area of the triangle? So I know area is base times height over 2, but I know that the base and the height have to have that 90-degree angle between them. So even though this triangle is kind of laid on its side a little bit, this can be the base, and since we have this 90-degree angle, this can be the height. It just looks different. That's okay. So that's 36 over 2, which is 18. And then the longest side of this triangle is opposite which angle? Well, these two are the same, but 90 is the largest angle. So the longest side is going to be opposite angle C. Okay, draw an equilateral triangle and show its lines of symmetry. So I'm going to do my best. It should go through each, yeah. Does an equilateral triangle have rotational symmetry? Yes, it's going to look the same as you flip it along. So you have a triangle, and then you have it again, and then you have it again, because all the sides are the same. No, they may not look the same, but that's because I cannot draw. Okay. Evaluate the absolute value. Remember, these straight lines mean absolute value. If x is 3 and y is 4. So let's see, this is the absolute value of 3 minus 4. So 3 minus 4 is negative 1, and we know the absolute value is always positive. So this equals 1. Oh, that's it. Okay, All right. Well, let me know if you have any questions. Have a great day.